management and integration is the glue that ties all the previous stages together. In this phase, the off-site and on-site elements are combined up until construction completion, and the building is prepared for handover to the client. The main difference between management for off-site projects compared to on-site construction is the need for different sequencing of trades. Instead of firstly building the foundation, then the superstructure, and finally the finishing works, the superstructure and the foundations are constructed at the same time but in different locations, on-site and in the factory. This difference will depend on the level of enhancement, on the amount of work carried out in the factory. If the project uses a timber panelized system, for example, the finishing trades typically represent 50% of the on-site labor. With volumetric or modular projects, including the internal finishes, appliances, fixed furniture and cladding, the percentage of work for on-site finishing trades is reduced. Their tasks also change, as they need to stitch the modules together. Stitching includes, for example, filling in the gaps around the module's corners with cladding so that the building facade is uniform and continuous. Alongside the opportunity to reduce time on site, another benefit of off-site construction site management and integration emerges: health and safety. As more work is transferred to a factory environment, the need to work at height on building sites is reduced. This is especially true in modular roof structures, which can also be built on-site next to the superstructure and erected using cranes with minimum need for finishing on scaffolds at height. In addition, in the lifting operations of subassembly panelized and volumetric systems, mobile cranes can be used instead of tower cranes. Some subassemblies and open panels with suitable weight clearly labeled can be lifted and handled manually without the need for equipment. Another key advantage of off-site construction systems for project management can be achieving strict environmental sustainability criteria. Due to the high levels of standardization and control in the factory environment, critical passive energy saving measures can be achieved in the building fabric. These can include thermal resistance with precise insulation of all components and no gaps between insulation and other elements, and airtightness or airflow between the internal area and the outside for careful taping of all openings for services and precise windows and doors installation. Despite important benefits, management and integration of off-site construction systems with on-site process can be challenging. One of the clearest examples of this is the interface between the floor slab and the ground floor off-site construction system. The groundworks and floor slab typically need to be constructed to stricter tolerances than with on-site construction. In the construction of the 7-story residential building in Yoker using cross-laminated timber, or COT for short, the floor slab had to be constructed within a few millimeters tolerance. Another main challenge is the precise coordination of the on-site activities with the off-site manufacturing schedule and logistics. In this way, the off-site and on-site activities need to be planned together. If done successfully, the challenge of effective program management and communication with the supply chain can enhance certainty of the final completion time for the project. 4D simulations, including the 3 dimensions of space, plus time added as a 4th dimension, can be useful to construct and analyze the building virtually before a single piece of dirt is disrupted on site. Several tools, part of the Building Information Modeling Suite, can be used to create these simulations. One of the most typical tools used for this is Autodesk Navisworks, although there are other providers such as Trimble or independent developers. These often include tools for health and safety analysis, as well as class detection and on-site real-time tracking of progress compared to the planned construction time. Indeed, in this direction lie the future opportunities for management and integration of off-site construction systems. With the development of technology, we anticipate we will see more augmented reality used for quality control during each construction stage. The same idea of a digital twin or a digital model representing the as-constructed building as accurately as possible can be used to store and communicate maintenance and replacement information for each building component. Just think about how much easier and quicker it will be to fix a faulty ventilation pipe or electric cable if there is an accurate digital model telling the tradesperson exactly where the services are located. Interestingly, construction models and virtual reality can be used during the lifetime of the building as tools to engage with the public and even spark interest in construction as a career. In summary, offsite construction management and integration is the most critical step of the building process, in which all the previous stages from design to on-site placement culminates into a finished product ready to be handed over to the client. The main difference between on-site and off-site construction is the challenge of scheduling the on-site activities alongside the factory operations so that they are synchronized. In practice, this can be achieved through increased use of construction schedule simulations in 4 dimensions, the 3 dimensions of space plus time. In the future, we expect to see more use of technology in off-site construction project management, such as digital twins for quality control and augmented reality for building component maintenance and replacement, closing the whole life cycle loop. Congratulations! You have now completed all off-site ready videos and are ready with knowledge for change to disrupt the construction industry. Be sure to check our website for further learning resources and spread the word about the Offsite Ready project. Many thanks to the Construction Industry Training Board for funding the Offsite Ready project, and huge thanks to our academic colleagues and industry leaders who helped with the creation of the Offsite Ready learning content.
From Edinburgh Napier University, City of Glasgow College, the Construction Scotland Innovation Centre, the Ministry of Building and Education, Class of Your Own, and the Construction Wales Innovation Centre.